Hi class, this is part 3 of section 5.4. We're up to example 5, so we'll graph the function f of x is x times x plus 4 quantity squared divided by x plus 2, x minus 3 quantity squared. Okay, so the domain of the function is everything except for -2 and 3. The function is already in factored form, so that's nice. Nothing cancels, so the vertical asymptotes are both x is equal to -2. X equals -2 and x is equal to 3. And there are no holes in the graph. Let's see, the horizontal asymptote, the numerator is degree 3, so I'm adding my exponents together. Denominator is also degree 3, so the horizontal asymptote will be the ratio of our leading coefficients, so y equals 1. X-intercepts, so the fraction will be 0 when the numerator is 0. So our x-intercepts are 0, 0, and also -4, 0. Y-intercept, let's plug in a 0 for x. Oh, and we'll have a 0 in the numerator, and then some other number, so 2 times 9 in the denominator. Right, so 0, 0 is our y-intercept. It was one of the x-intercepts, so it had to be the y-intercept as well. Okay, so our vertical asymptotes, there's one at x is equal to -2, one at x is equal to 3, and then our horizontal asymptote at y equals 1. Our graph is going to go through the origin and also -4, 0. Okay, so a couple things are different about this function. So -4 is a 0 with multiplicity 2. So the graph will touch at that x-intercept. Okay, so the zeros, we have 0 and -4, multiplicity 1 and 2, so we'll cross at the origin but touch at x equals -4. Okay, we also have a horizontal asymptote, so the graph is kind of coming from this horizontal asymptote. We're going to touch the graph at -4, which means we're going up to positive infinity as x gets closer to -2. Okay. The graph will be crossing at the origin. So since x plus 2 is raised to the first power, I know that the function will go to 2 different infinities on either side of that asymptote. However, I now have x minus 3 quantity squared, so the graph will go off to the same infinity. Okay, plus I need to stay away from the x-axis over here on the right because I do not have another x-intercept. So I knew that I had to be above this horizontal asymptote going off to positive infinity. Okay, so here's our graph with the vertical asymptotes and our x-intercepts plotted. And here's the graph drawn on Desmos. Okay, these are the 3 for you guys to complete and turn in through Canvas. I'm looking for basically what we've been talking about. So graph the function, include the asymptotes, intercepts, holes if there are any. You're allowed to put in additional points either to check your work or because you're not sure which way the function's going. State the domain of the function, use either interval notation or set builder notation. Okay, and you have 3 functions to do. Okay, I have 2 more examples. If you feel like you've seen enough examples, you can go ahead and stop the video. But if you want to see 1 or 2 more, keep watching. Okay, so here's our extra examples. Start off by factoring. So the denominator will factor to x plus 4 times x plus 2. So the domain, everything except for -4. Nothing cancels, so those are both going to be vertical asymptotes. X equals -4, x equals -2. Horizontal asymptote for this graph is y equals 0. So the degree of the numerator is 1, but the degree of the denominator is 2. So if the degree of the denominator is bigger, that's when y equals 0 is our horizontal asymptote. So the x-intercept is when the numerator is 0, so that's the point 1, 0. The y-intercept will get 0, -1/8. So I was looking here to the original, let x equal 0, and we'll get -1 in the numerator, +8 in the denominator. Okay, quick sketch of the graph. So vertical asymptotes at -4 and also at -2. Our horizontal asymptote is right on the x-axis, 1, 0, and 0, -1/8. Okay, good. We don't have a whole lot, well, we're actually okay. So I'm gonna, starting on the right-hand side over here. So again, our graph is in 3 sections, okay? Make sure there's 3 portions to your graph. I have a vertical asymptote here, so I must be coming from -infinity to go through my y-intercept and then x-intercept. And then the graph kind of turns and comes back because the line y equals 0 is my horizontal asymptote. So the graph is positive here, but quickly goes back down towards that asymptote. Okay, I don't have anything quantity squared in the denominator, so I know that that I have to be at the other infinity on the other side of -2. Okay. Also, there's no more x-intercepts. So the graph is up here going off to infinity, both on the left side of -2 and also on the right side of -4. Okay, and then I also must be down here in quadrant 3 because on either side of x equals -4, I have to go to the opposite infinities. Okay, this is actually a nice one to plug in points to check. Okay, so here's our graph. I'm going to plug in some points now. Let's plug in a 1, and maybe this is easier in factored form. So x plus 4, x plus 2 over x minus 1. Oh, well, 1 was our x-intercept. So we'll do 2. So if x is 2, I'll have 2 minus 1, or 1 in the numerator, and then 6 times 4, so 1/24. So I get this small positive number. I had my y-intercept sketched, or drawn in, I should say. Right, so at 2, we're at 1/24, so this small positive number. Okay, let's try -3. So it should be a positive value. So -3 minus 1 is going to give us a -4 in the numerator. -3 plus 4 is 1. And then -3 plus 2 is -1. So we do, in fact, get +4. This is higher than what I had graphed, but again, it's just a sketch. You're making sure that you're on the correct side of the x-axis and going towards the correct infinity. Okay, good. We don't know that -3 is the lowest point. We just know that the graph goes through -3, 4. It could look something like that, right? We don't know that this would have to be the lowest point, but again, it's just a sketch, so it's fine for you to make it the lowest point, like I had the first time. Okay, and then let's just check -5. So again, I had it graphed down here in quadrant 3. So we're just making sure that we get a negative value back. Okay, in the numerator, so negative 5 minus 1, I'll have a negative 6. In the denominator, negative 5 plus 4 is negative 1, and negative 5 plus 2 is negative 3. So we have 3 negatives, so our final answer, it worked out to be negative 2. Good, so this would have been here, and then going towards your asymptotes. So there's a rough sketch of the graph. And here it is drawn on Desmos. For some of these functions, the values are so small, so we're coming from below the x-axis. We know that the x-intercept was at 1, 0, and so then you have to cross it and approach it from above. Okay, so yours is going to be a bit exaggerated. That way I can see that this line is in fact above that horizontal asymptote. It's just so close to it. The numbers are very small, very close to 0. Okay, and then here's one more. The denominator, right, start by factoring that, x plus 4, x minus 2. So that's our domain, everything except for negative 4 and 2. Factor the numerator. This factors to x minus 1 quantity squared. Okay, so the two vertical asymptotes, x equals negative 4, x is equal to 2. Horizontal asymptote, y equals 1, x-intercept 1, 0, y-intercept 0, negative 1/8. So here's our asymptote at x equals negative 4, another one at x is equal to 2. Let's see, I'll put in the horizontal asymptote at y equals 1. Okay, 1, 0 is our x-intercept, 0, negative 1/8 is our y-intercept. Good. One thing different about this problem is that if we were to give, okay, so the only 0 we have is 1. If we were to give it a multiplicity, it would be 2, which tells us that the graph should touch. Okay, so we would have been coming from this negative infinity. We'll go through our y-intercept. The x-intercept we would just touch, meaning we come back down and go towards negative infinity. And the right side of our graph, we have to stay away from the x-axis. So we'll come from infinity and go towards our horizontal asymptote. Same thing here on the left. Okay, so we're off at positive infinity and then go towards our horizontal asymptote. Both of these guys in the denominator are simply raised to the first power. So again, your function should be going to opposite infinities. Okay, so here's our function in factored form. And then here's the graph. Oh, one thing I didn't do is my graph was solely up here. Okay, and for a quiz or for a test, that would be fine. If you want to know, and I did this once before, if you want to know if your graph is going to cross that horizontal asymptote, okay, what we do is we set the function equal to the horizontal asymptote. So our horizontal asymptote was y equals 1. So we set that equal to x minus 1 quantity squared over x plus 4, x minus 2. And let me multiply this out. So x squared minus 2x plus 1 in the numerator, x squared plus 2x minus 8 in the denominator. So cross multiply, we get x squared plus 2x minus 8 is equal to x squared minus 2x plus 1. Subtract x squared from both sides, those will go away. Add 2x over, so we then have 4x. Let's add 8 over, so we'd be at 9. So x is equal to 9/4, or 2 1/8. So that tells us that if our x value is just a little bit to the right of 2, we would be crossing the horizontal asymptote. So this is an example where we were coming from infinity, but we do cross that asymptote and then approach it from the other side. Okay. This, I drew it more like I had here on the left, where the function stays above that horizontal asymptote the whole time. Okay, but on the right side, it does the opposite. It crosses and then approaches it from below. Okay, good. That's it. I know that this is a tough section, so I hope I gave you enough examples, but please let me know if you have any questions. And good luck on your 3 lecture question problems.